Hello, my name is Keshwani. 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 We are here because we want to learn algebra. Today is our day number 39, lesson number 39. We have to subtract one algebraic expression from the other. So here's the problem. We are told to subtract two AB minus 3BC plus 4AD plus 5CD from 5AB, that's the 5, 5AB plus 3BC minus 7AD minus 3CD. Let's see if I copied it properly. 2AB minus 3BC plus 4AD plus 5CD, and we are asked to subtract that expression from 5AB plus 3BC minus 7AD minus 3CD. Now, I've been explaining it. We've been at it for now 2 or 3 days now. I started, I think, adding and subtracting. We started the subtracting of the expression on day number 37, I believe, 37, 38. Today is our third day. It's very important that you watch the videos in sequence so that I don't see don't see the need to explain all the concept over and over again. But I'm going to quickly do it here just to make you understand. For example, if you're asked to subtract, if you're told subtract 10 from 12, subtract 10 from 12, that's the question here. Even though this 12 appears at the bottom, in order to do what we are told here, subtract 10 from 12, we have to write the 12 on the top and then 10 at the bottom, and then subtract it. The same exact thing is going on here. What we are asked to subtract from, the expression that we are asked to subtract from, has to go on the top. So this expression, second expression, has to go on the top. 5AB plus 3BC minus 7AD minus 3CD. And what we are being asked to subtract has to go at the bottom. We are being asked to subtract this expression, which has to go at the bottom. Second thing we have to understand is that, you see here we got the answer of 2. How did we get the answer of 2? In the language of algebra, what's going on here is that when somebody asks you to subtract 10 from 12, in the language of algebra, what is going on is that you get 12 minus the positive 10. This is how we write in the language of the algebra. You must write it like this. 10 has a positive sign in front of it. 12 has a positive sign. So positive 12 minus a positive 10. That's how we write in the language of algebra. And then this positive and negative become negative. So what we end up is a positive 12, a negative 10, giving us a positive 2. This work that you see there is in the formality, it observes the formality of the algebraic language. This is simple arithmetic. In simple arithmetic, you can get away with this thing. But in the language of algebra, you have to write a positive 12, a positive 10, and then the sign of the positive changes to positive 10 has to change to negative, like that. And then we add the two numbers, positive 10, positive 12, and a negative 10 gives us positive 2. Same exact thing is going on here. All of the signs of the coefficient of the bottom expression, all the signs of the coefficient of the bottom expression have to be changed, and after the signs are changed, we simply add the two coefficients. That's it. So this positive 2 becomes a negative 2, this negative becomes positive, this positive becomes negative, and this positive becomes negative. Now that the signs are changed, all we have to do is just add up the coefficient. This is a positive 5. Positive 5 and a negative 2 is going to give us positive 3, AB. And since it's positive, we don't need to write it. A positive 3B, positive 3BC, and a positive 3 and a positive 3 is going to give us 6BC. Which, if you think about it, makes sense. Because let me erase this part so we can actually see it. To see where this positive 6 came from, you see, we were asked to subtract a negative 3 from a positive 3. So here we have a positive 3, and we are being asked to subtract a negative 3 from it. Well, how do you subtract this negative 3 from a positive 3? This is how we write it. And the negative and negative becomes positive, which is what we're showing here. That this negative is going to turn into positive. And of course the answer to this thing is positive 6, right here. Same thing is going on here. We're being asked to subtract negative 4. We're being asked to subtract negative 4 from a negative 7. So this negative and negative is going to become positive. So what we have is negative 7 plus a positive 4, giving us a negative 3. Except that's not what I'm getting here. Oh, we're being asked to subtract positive 4, sorry. We're being asked to subtract positive 4 from a negative 7. So this positive is going to become negative. Negative plus positive is negative. And we're going to end up with negative 11. Right here. Negative 7 and negative 4 is going to give us negative 11. Same thing here, a negative 3 and a negative 5 is going to give us negative 8 CD. That's your answer. Negative 8 CD. Let's do one more, shall we? Let's do one more. That was the answer to this problem. We are asked to subtract negative 2xy plus positive 4xz minus 5yz from 8xy minus 3yz plus 6xz. So we write the bottom expression first, 8xy minus 3yz plus 6xz, and then we write the top one, negative 2xy, positive 4xz, negative 5yz, and then we have to change the sign of the coefficient of the bottom expression. This negative becomes positive, this positive becomes negative, and this negative becomes positive. And then all we have to do is add up the coefficient. This one has a positive sign here, positive 8 and positive 10. This positive 2 is positive 10xy. Aha! Negative 3yz and negative 4xz. Negative 7yz. Positive 6 and a positive 5 is positive 11xz. This whole thing is wrong. It's wrong. We must add up the like terms together. These were like terms. Here's the xy and here's the xy. But these are not like terms. We cannot go around adding yz to xz. We cannot go around adding x times z to y times z. For example, if I ask you, if I have 5 times 2 times 3 and 3 times 2 times 3, how many 2 times 3 do I have? I have 5. This thing equals 5. Sorry. We have 8 2 times 3. The 2 and the 3 are your y and the z. So if somebody asks us 5 times 2 times 3 plus 3 times 2 times 3, if somebody asks you to combine the like term in the context of arithmetic, what they're asking you is how many 2 times 3 do you have? Because these 2 and the 3 are your variables. Let's say y equals 2 and z equals 3. So y times z, 5yz plus 3yz. So in the context of the algebra, what they're asking here is how many 2 times 3 do you have? And the answer is we have 8 2 times 3. We have 8 2 times 3. But what happens if instead of a 3, I have a 5 here? Then the question of how many 2 times 3 do you have, no, I shouldn't have changed it here, let's leave it here the way it is, and we'll do it in a different color. I forget what z was 3. Here we have 8 z times y times z. But what happens if we had something like this? Let's raise this part here. 5 2 times 3 plus 7 2 times 5. Well, here they are no longer like terms. They are different. They are different variables. If your y is 2 and your z is 3, then this is y times z. We have 5 yz. If your y is 2 and your z is 3, this must be some other variable. This must be x. Your y was 2, so your y is 2, and this 5 must be different variable x. So here you have y times z and here you have y times x. We cannot add them. If somebody asks you if somebody asks you to combine the like terms here, what they're asking you is how many y times z do you have? How many 2 times 3 do you have? Well, I have 5 2 times 3. How many y times x do I have? Well, how many x times y? How many y times x do you have? I have 7 of them. We have 7 2 times 5. 7 2 times 5 and 5 2 times 3. They cannot be combined together. They cannot be combined. They are not like terms. Y times z cannot be added to x times z. We forgot to line them up properly. This y times z should have been lined up with this y times z. This should have been moved here, and this guy should have been moved here. X times z should go under x times z. This is all wrong. We have to redo it. This is all wrong. Let's redo it properly. We're going to redo it. Just give me one brief second and I'll be right back in the camera. Don't go away. I'm still here. I just quickly have to check something. Alright, let's quickly finish it up. 8xy minus 3yz. Instead of doing it on the bottom, I'm going to redo it on the plus 6xy. And then we have negative 2xy, negative 2xy, so I can put it here because this is xy. Then we have negative 3yz, negative 3yz. Oh, sorry, we are subtracting this expression, so that expression has to go at the bottom. So we have negative 2xy that went here. Then we have 4xz. 4xz should come here, 4xz. And then we have negative 5yz. Negative 5yz should line up with yz. And now we have to change the sign of the coefficient. We have to change the sign of the coefficient. This negative becomes positive, this negative becomes positive, this positive becomes negative. And once the signs are changed, all you have to do is just add up the coefficient. Positive 8 and a positive 2 will give us positive 10 xy. Negative 3 and a positive 5 will give us positive 2 yz. Positive 6 and a negative 4 is going to give us positive 2 xz. And there you go. That's your answer. I'm going to go in the back of the camera one more time because I'm paranoid. I want to see how far down that you can see. And if there is a need, I'm going to redo it on the top. But just give me 1 second before I call it a day. Just want to check briefly. Everything seems to be, as they say in Minnesota, where I used to live in the Midwest, everything seems to be hunky-dory. I'll see you tomorrow on day number 40. We are done for today. I'll see you tomorrow on day number 40. In the meantime, if you wish to get hold of me, you can send me an email or you can call me on my toll-free number by going to any of these website addresses that you see or by going to kashwaniprep.com. Alright? I'll see you tomorrow. Bye.